What is a black hole? How many types of black hole? What is inside of a black hole? Is black hole danger for the universe? Black hole danger to Earth? What is a black hole? A black hole is a region in space where gravity is so strong that nothing, not even light, can escape its gravitational pull. It is formed from the remnants of a massive star that has undergone gravitational collapse, typically after a supernova explosion. The gravitational force of a black hole is generated by an extremely dense and compact core known as the singularity. The singularity is surrounded by an invisible boundary called the event horizon, which marks the point of no return. Once an object crosses the event horizon, it is effectively trapped within the black hole and cannot escape. Black holes come in different sizes, ranging from a few times the mass of our Sun to supermassive black holes found at the centers of galaxies, which can contain millions or even billions of times the mass of the Sun. The size of a black hole is determined by its mass and density. Black holes have various observable effects on their surroundings. For example, they can distort space and time, causing a phenomenon known as gravitational time dilation. They also have powerful gravitational forces that can influence the motion of nearby objects, such as stars and gas clouds. Although black holes cannot be directly seen, scientists can infer their presence through the effects they have on nearby matter and light. This includes the emission of X-rays and other high-energy radiation from heated matter falling into the black hole, which can be detected by telescopes. How many types of black hole? There are generally 4 types of black holes that are commonly recognized based on their mass and formation processes. These types are stellar black holes. These black holes are formed from the remnants of massive stars that have undergone gravitational collapse after a supernova explosion. Stellar black holes typically have a mass ranging from a few times to several tens of times the mass of our Sun. Intermediate mass black holes. These black holes have a mass greater than stellar black holes, but smaller than supermassive black holes. The exact range of masses for intermediate mass black holes is still a topic of research and debate among scientists. They may form through various processes, such as the merger of smaller black holes or the direct collapse of massive gas clouds. Supermassive black holes. These are the largest type of black holes observed in the centers of most galaxies, including our own Milky Way. Supermassive black holes have masses ranging from millions to billions of times the mass of the Sun. The exact mechanism for their formation is still not fully understood, but they are thought to grow over time through the accretion of mass and the merging of smaller black holes. Primordial black holes. These black holes are hypothetical and are not directly observed. They are believed to have formed in the early universe, shortly after the Big Bang. Primordial black holes could have a wide range of masses, from tiny ones that have evaporated by now due to Hawking radiation, to much larger ones that could still exist today. It's important to note that the classification of black holes is not strictly defined, and there may be other types or subclasses that emerge as our understanding of these objects continues to evolve through ongoing research and observations. What is inside of a black hole? The inside of a black hole is a region that is still not fully understood, and our current understanding of physics breaks down at the center of a black hole. According to general relativity, which is our current theory of gravity, the center of a black hole is a point of infinite density and curvature known as a singularity. The singularity is surrounded by an event horizon, which is the boundary beyond which nothing can escape the gravitational pull of the black hole. Anything that crosses the event horizon, including matter and even light, is believed to be trapped within the black hole and is effectively cut off from our observable universe. Inside the black hole, the gravitational forces become extremely strong, causing space and time to be severely distorted. This distortion is known as spaghettification, where the gravitational tidal forces stretch and compress objects along different directions. It is theorized that as an object falls towards the singularity, it would be stretched into long, thin strands resembling spaghetti. However, our understanding of what exactly happens inside a black hole is limited because the laws of physics, as we currently understand them, break down at the singularity. To fully comprehend the behavior of matter and spacetime within a black hole, scientists are actively researching theories that merge general relativity with quantum mechanics, such as string theory or loop quantum gravity. It's important to note that the concept of a singularity is a mathematical description and may not accurately represent the true nature of what lies inside a black hole. Further research and advancements in theoretical physics are required to gain a deeper understanding of the interior of black holes. Is black hole danger for the universe? Black holes in general are not considered a danger to the universe as a whole. They are natural consequences of the laws of physics and play important roles in the evolution of galaxies and the universe at large. While they have powerful gravitational forces, they do not pose a threat to the overall stability or existence of the universe. Black holes primarily interact with their surroundings through gravitational attraction. They can accrete matter from their surroundings, including gas and stars, which releases large amounts of energy in the form of radiation. This process can influence the growth and evolution of galaxies. However, the influence of black holes is limited to their immediate vicinity. The gravitational pull of a black hole diminishes rapidly with distance, and their effects are typically confined to a relatively small region compared to the vastness of the universe. On a cosmic scale, black holes contribute to the cosmic web, which is the large-scale structure of the universe consisting of clusters, superclusters, and filaments of galaxies. They play a role in shaping the distribution of matter and in the growth and evolution of galaxies through processes like galaxy mergers and the feedback of energy and matter. While black holes can be destructive on a local scale, such as through the tidal forces experienced near the event horizon, they are not considered to be a threat to the overall stability or existence of the universe. The universe is governed by a balance of various forces and factors, and the presence of black holes is one element in this complex interplay. Effects of black hole. Black holes have several profound effects on their surroundings and the surrounding spacetime. Gravitational attraction. Black holes have an extremely strong gravitational pull due to their immense mass. This gravitational attraction can significantly affect nearby objects, such as stars, gas clouds, and other celestial bodies. It can cause them to orbit, spiral in, or even be torn apart if they come too close. Time dilation. Black holes have a strong gravitational field, which leads to a phenomenon called gravitational time dilation. Time passes more slowly near a black hole compared to regions with weaker gravitational fields. This effect has been observed and measured in experiments and through the study of objects orbiting black holes. Spacetime distortion. Black holes warp and distort spacetime in their vicinity. The intense gravitational forces near a black hole cause spacetime to curve, leading to the bending of light and the deflection of particles that pass near the black hole. This distortion is responsible for the phenomenon known as gravitational lensing, where the path of light is bent around a black hole. Accretion disk and jets. Black holes can have an accretion disk, which is a rotating disk of gas and dust that forms as surrounding matter is drawn towards the black hole. Friction and gravitational forces heat up the material in the disk, causing it to emit intense radiation, including X-rays. In some cases, black holes also generate powerful jets of high-energy particles that shoot out from the vicinity of the black hole's poles. Event horizon and information loss. Anything that crosses the event horizon of a black hole, including matter and information, is believed to be lost to our observable universe. This concept is known as the information loss paradox and is still an active area of research and debate in theoretical physics. These effects of black holes have significant implications for the structure and evolution of galaxies, the dynamics of star systems, and the behavior of matter in extreme gravitational environments. The study of black holes continues to provide insights into fundamental aspects of physics and the nature of the universe. Black hole danger to Earth. Black holes located far away from Earth do not pose a direct danger to our planet. The likelihood of a black hole coming close enough to Earth to cause harm is extremely low. However, if a black hole were to pass through our solar system or approach Earth at a relatively close distance, it could have catastrophic effects. The intense gravitational forces of the black hole would disrupt the orbits of planets, including Earth, leading to significant changes in their trajectories and potentially causing collisions. The tidal forces near the black hole could tear apart celestial bodies in its vicinity. That being said, the probability of such an event occurring is extremely remote. Black holes are formed from the remnants of massive stars and are relatively rare in the galaxy. The chances of a black hole coming close enough to Earth to cause damage are incredibly low. Scientists actively monitor the skies for any potential threats, including objects that could pose a risk to Earth. The field of astronomy and astrophysics is dedicated to understanding celestial objects and assessing any potential risks they may pose. Based on current scientific knowledge, there is no immediate danger to Earth from black holes. It's important to maintain a balanced perspective and rely on scientific evidence when considering the potential dangers from black holes or any other cosmic phenomena. That's all in this video. If you like the information, please hit like and subscribe to this channel. and be connected to this channel for more space information.